Hello, welcome to this video. In it, we are going to see some of the definitions about IoT, Internet of Things, and detail the main components that form an IoT system. I am Marcos García Alberti, and this is the Model 3.2. In previous videos, we have seen how this technology has been evolving during the years, passing from RFID concept to the final IoT technology. It's about 2010 when multiple definitions of IoT are defined by different authors. As we can see in the picture, some authors define IoT as a global infrastructure of information that makes possible the physical connection of devices, people, and systems through communication technologies, providing intelligent automated services. As it is seen in the picture, IoT could be understood as a system of different oriented visions focused on things, internet, or semantic aspects, and the mix of these three entities entails the concept of IoT. In 2011, IoT was defined as an emerging concept which describes a global information infrastructure based on interconnection of physical objects through communication technologies, allowing data collection and data analysis in real time. As well as in previous definitions, IoT is also formed by different parts, as we can see in the slide. For instance, the Internet Protocol, new communication technologies, devices, or applications. Other definitions of IoT place more emphasis on the availability of the data and the sharing process. In this regard, it must be highlighted that IoT systems have the possibility to share information with other systems with no IoT devices installed. Therefore, the concept of sharing information and data availability outstands in any IoT system. Along the years, it seems that the definition of IoT has been established and common concepts are repeated by different authors. Considering previous definitions, IoT could be commonly considered as a network for physical devices that collect and share different types of data. However, if IoT is a common online network, is an IoT connection the same as Internet connection? Of course, IoT connectivity is based on an Internet connection. However, there are some differences. For instance, the scale of connection. In an IoT connection, the scale could be quite reduced, focused only in some devices to get some information. However, in an Internet connection covers a global network. Another main difference is the communication protocols. While Internet uses traditional protocols like TCP or IP, Internet Protocol, IoT uses reduced protocols adapted to low energy and capacity devices like MQTT. Therefore, IoT is considered an Internet evolution for connected devices, focused in data autonomy and connectivity. In order to adapt to this new Internet evolution, the IoT new technology, many efforts to standardize the communication processes has been carried out. Different protocols have been developed in order to ensure the fastest and safest IoT connection. It must be considered that a simple device can trigger a great amount of data in just a few seconds. Therefore, speed and data reliability is essential for real-time tools. IoT protocols are used to achieve it. According to many different authors, CoAP and MQTT protocols seem to be the fastest and the most stable ones for data connectivity between tools and IoT devices. A deeper definition of protocols, components, and IoT implementation examples will be detailed in the next video. Here you can find also some reference used for this presentation. And this is all for this video. Thank you very much for your attention. Remember that this is co-funded by the European Union through the Master of Digital Twins for Infrastructures and Cities. And thank you again for your attention.